In this video, we're going to talk about the complete unit circle, and hopefully by now you're like, oh man, the unit circle again. We've done this 4 times. I already know how to do this. That's a good thing. If you're like, okay, I already know how to do this, watch the video at 2 times speed. All right, but if you forgot how to do it, all right, we're reviewing it because it's important. We've done it a bunch of times because it's important. A lot of math is built off these sine and cosine values, so knowing the unit circle is important. All right, so let's review how to put it together, because once you have the unit circle, sine, cosine, tangent, all those become much simpler when you have your unit circle together. So we're going to start off with our fully blank unit circle. And the thing I always kind of remind students is you could remember all, what is this, like 45 blanks or something like that. You could do that. But if you're trying to remember 45 individual things without seeing the connections, there's a lot of chances for mistakes. So instead, we want to memorize the least number of things and then remember the connections between them. You're less likely to make mistakes when you have connections rather than just individual pieces of information. All right, so the part you do have to memorize is one, not too difficult, it's a unit circle. Unit means 1. So this is my xy axis. If I start in the middle of my xy axis, I can go right 1, get that point, go up 1, get that point, go left 1, get that point, and go down 1 and get that point. All right, the other thing that's going to be useful to kind of have memorized is that these bigger gaps are 30 degrees and the smaller gaps are 15 degrees. That'll kind of give you the angles here. And then your values along the unit circle, you kind of had to have quadrant 1 memorized. But again, there's some tricks. This middle one, they're the same. All right, so the square root of 2 over 2, 1, they're the same. It's in the middle. And then you just have to make sure you get these two in the right order. Most people have the numbers memorized. All right, 1's the square root of 3 over 2, 1's 1/2, but which one goes where? There's a couple different ways you can do this, and I kind of switch back and forth between them depending on how I'm doing the unit circle at that time. The first one is 1/2. If my x value is 1/2, you can see that perfectly lines up with the middle of the x-axis. So if I have this picture in front of me, that's kind of one thing I'll remember. So I go up to y is 1/2, that lines up with that point when y is 1/2. So visually, you can get your 1/2s in the right place, and then you can get the square root of 3 over 2's in the empty spots. The other thing is kind of useful. If you put the square root of 3 over 2 in a calculator, you get like 0.8. Square root of 2 over 2 is like 0.7. Again, there's more decimals after those, and the 1/2 is 0.5. All right, so I tell you this to tell you that the square root of 3 over 2 is the biggest. So if I'm starting at 1, the next thing I should get is the biggest value, and the next biggest value, then the smallest value, and then I'm down to 0, the absolute smallest. So these are going in decreasing order for my x values. My y values are the opposite. They start at 0, so now you should get the smallest one, then the middle one, then the biggest one. All right, so all these different things are different ways to remember these connections, remember them going in the right place. I do this kind of decimal 1, knowing that in this place, the x value is the bigger one, so that's how I mostly remember them. Once I have this down, I can get everything else around the circle pretty quickly. All right, first of all, the angles, we know the big gaps are all gaps of 30, so I'm just adding 30 to my angle. And the small gaps are all 15. So I'm just adding 15 to my angle to get the next angle each time. It's not on here, but the last one is all the way back around 360. All right, so we got the angles, and now I want to get the points around the outside. And just remember the points are related. This kind of 30-degree triangle is the same as this 30-degree triangle. It's the same as this one. It's the same as this one. The only difference between these triangles is the direction they're going. So if I'm thinking about my xy axis, to go up here, I have negative x's and positive y's. To go down here, both coordinates are negative. To go over here, I've gone down, so y is negative, but x is positive. All right, so just kind of knowing all of these points have the same. And in general, I don't go like draw these triangles. I just know if I go straight across, those are the same values with the negative, straight across, those give me all the same values. All right, same thing with my next 45-degree angle. All right, I could copy this triangle down 4 times, or just know I go straight across, I get the same values, straight down, I get the same values, straight across. All right, so this little box here, they all have the same values, negative x, negative y, both are negative. And my last one, straight across, straight down, straight across, straight up. All 4 of these have the same values, just with the negatives in the right place. All right, so now we have our unit circle completed. This is kind of the first way we learned it. It has all the angles in degrees and all the values. And now we just need to figure out the last thing, which is the radian measures. All right, so I'm going to give you two different ways to figure out the radians. The first one is you kind of just have to have these ones memorized. Again, we're trying to memorize the least amount as possible and remember other connections. But there is a little bit of help that these are just decreasing numbers, 6, 4, 3, 2. We skip 5 because it's not a nice value, but 6, 4, 3, 2. All right, easy to get in the right order because if for some reason you mixed up 6 and 3, which happens sometimes, they'd be out of order. So at least they're in order even though you skip 5. All right, just like with the values, the denominators of these angles follow the same straight down thing. So if I go straight across, the denominators are still 3, 4, 6. And then how do I get the tops? In the top here, I take the bottom minus 1. Why am I doing the bottom minus 1? Well, all the way around is pi, which would be like 6 pi over 6. And I'm going to go a little bit less. I'm going to go backwards a little bit, so I subtract 1 from that number to get 5. Subtract 1, subtract 1. And quadrant 3, again, if I do my kind of straight line stuff, if I actually make them straight lines, I can get the bottoms of the fractions because they're the same as their counterpart. And in this case, now I'm a little bit more than pi, so instead of subtracting 1 from the bottom, here I take the bottom. Oops. And I add 1. So 6 plus 1, 4 plus 1, 3 plus 1. And fourth quadrant, again, straight lines across to get the bottom of my fraction. And these ones are like quadrant 2, except for now I'm close to 2 pi, so I'm going to take double the bottom. And I'm going to subtract 1. So 12 minus 1, 8 minus 1, 6 minus 1. All right, so before I go into the new thing, this is kind of the way I do it most of the time, filling in all the degrees by just adding 15s and 30s in the right order, writing these ones down and just going straight down, straight across to get all the numbers in the right place, and then filling out the radians by putting these ones here, subtracting 1 from the bottom, adding 1 to the bottom, doubling and subtracting. So that's the way I actually do it every single time. So that's why I'm teaching you the same way. But there's a lot of other connections you made. I've had students who just remember the top values, so you can just put those in the right order. There's one other way. We'll talk about how to get the outside or the radian values in a second, but everything else, all right. Degrees I think is the most simple. Add 30, add 15, add 15, add 30, 30, 15, 15, 30, 30, 15, 15, 30, 30, 15, 15, 30. And it seems like I was adding those really quick. It's partially because I have seen these values so much they are like partially memorized, but also if you see them, you kind of know what to expect. Next, I kind of start with these values. Just remember them. I'm on the XY plane. I'm just going 1 in each of the cardinal directions. All right, next I can fill in these numbers. So this one, if I started at 1, the next one's the biggest of the 3 values, which is the square root of 3 over 2. Then the smaller one, and then the smallest one, which is 1/2. It's also 3, 2, 1 to know it's getting smaller. And then I do the opposite for the y values. Now that I have those numbers, I can get the rest of the numbers by just going straight across. So this is negative 1/2 square root of 3 over 2. As the x values are negative in this quadrant. The way I'm doing it now, I'm doing it as a group, but also I normally would probably just do like each number separately, but now I can go straight down for each one. They're both going to be negative. And then go straight across for each of them, and just the y value is negative. Again, just double check that everything kind of in the middle here has the same square root at this start, everything in the middle here at the 1/2 at the start. It all looks good. Right. Now last is radians. We have 0 to start, pi over 6. They're going down, pi over 4, pi over 3, pi over 2. All right, and you can do it the way I showed in the earlier slides. This is adding 1 to the bottom. Sorry, this is subtracting 1 from the bottom, adding 1 to the bottom, doubling, and subtracting 1. But there's one other way you can do it by just using multiples. So each of these big gaps is a pi over 6 gap, and these two combine to a pi over 6 gap as well. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pi over 6 gaps going around. So I have pi over 6. I do another one. This would be 2 pi over 6, which simplifies down to pi over 3. This would be 3 pi over 6, which simplifies down to pi over 2. This would be 4 pi over 6, which simplifies to 2 pi over 3. We skip this middle one because we're jumping this double length. So this one would be 5 pi over 6, which doesn't simplify. This one would be 6 pi over 6, which does simplify to pi. 7 pi's over 6, which doesn't simplify. This one is 8 pi over 6, which does simplify to 4 pi over 3. 9 pi over 6, which simplifies to 3 pi over 2. Now we're at 10 pi over 6, which simplifies to 5 pi over 3, if I simplify it. And 11 pi over 6, which simplifies to 11 pi over 6. And 12 pi over 6, which simplifies to 2 pi. All right. Now it's erase the stuff that isn't necessary around the outside. I can't really erase that one. It's too close. So you can use these gaps of pi over 6 to kind of fill in a lot of it. We're missing the middle ones in each region, and the middle ones is half of each quadrant is a pi over 4 gap. All right, so we can go pi over 4. 2 pi over 4 is also pi over 2. 3 pi over 4 doesn't simplify. 4 pi over 4 is also pi. 5 pi over 4 is 6 pi over 4 simplifies to 3 pi over 2. 7 pi over 4. And 8 pi over 4 is also 2 pi. All right, so that's another way you can do this if you want to kind of use the same kind of 30-15 type thing. You just have to make sure you simplify your fractions so that when you're doing sine and cosine values, you can recognize them in their simplified form. Again, I'm not going to tell you which way to do. You can even come up with another way if there's some way that makes you happy to remember it. By this point in the semester, you kind of have your method, but I just want to give you as many methods as possible so that you can really nail down and do this quickly and efficiently and try to make the least mistakes as possible. Because again, if you can do the unit circle well, you can do sine and cosine very simply.